Okay, Bismillahirrahmanirrahim. As this video is about how you can build different models for classification of objects and how you can create a virtual environment for the Python project. So basically, we will start from creating a virtual environment, and then we will install libraries in it, and then different packages, and after that we will import those libraries and use those libraries in our program. So basically, we will start from like first we have to create a folder. So I have already done it, so I don't have to do it again. So you can create any kind of folder. So once you have created, there will be nothing like this. So you will just click here and then you have to type cmd. So it will open command prompt at this position, at this exact position. So using this prompt command window, you will be able to create a virtual environment, and the command that you have to use is it's like python and slash m v. So here you can write anything like whatever you want, and then after this you have to give the address of the folder in which you want to create the virtual environment. So for that, for the instance, like if I'm using this folder, so while just I have to just click on left click on this button for once, and here I will go to copy path. I'll copy its path and then I'll just paste it here. So it will be like it will create a virtual environment. So as I have already created it, so I'm not doing this command again. So what I'm basically doing is, so once you have created it, you will have few folders here like virtual environment and then archives and checkpoints, etc. So after that, once you have done that, so you will just you will have to open up the Jupyter notebook. And for using this, I hope you have installed Jupyter notebook. So for that, you will use that like the command Jupyter notebook. So what basically it will do is it will open up the Jupyter notebook. So as you can see, it's open for me. So I'll just pick it up in the new window here. So again, you will have the display of your folder. So everything in your folder will be displayed here. So I have a lot of things in my folder, so that's why it's showing a lot of things. So you will basically only have one file, or if you don't have any file, you just have to click here new and then python 3. So it will create a new file for you. So I have already created it, so I'll just click it and it's running here. Okay, so this is basically the code, so you don't have to understand it now for the time being. And after you have done all these things, so what you have to do now is you have to install the libraries. So for installing the libraries, you have to again open up the command window here, and you have to activate the virtual environment. So you will write venv activate and then script. So this is the command to activate the virtual environment. So basically, the virtual environment, the purpose of virtual environment is that whenever we create a virtual environment, we like specify a kind of environment, we specify boundaries for the program. So if I will install anything in this virtual environment, so it won't affect the whole computer. So anything in the laptop other than virtual environment, so the program and the libraries won't affect that. So that's the actual reason of using virtual environment. Oh, wait a second. What's not working? And I think I just done it wrong. Virtual environment scripts activate. Yep, it's activated. So I was just doing it wrong. So this is the actual way to activate your virtual environment. So once you have activated it, you will need a few essential libraries that we are going to use in our project. So like basically you need a TensorFlow, you need a CV2, and then you need this one, and then you need Matplotlib, NumPy. So some of them will be installed like with other libraries. So first of all, like the commands, we have different commands to install all these libraries. So let me mention all these here. Wait a second. So basically the syntax of writing the commands is like first you have to write pip, then you have to write install, and then you have to write the name of the libraries that you want to install. So first one is OpenCV. So this is the basic one. So I've already installed all of these, so I'm not pressing enter. So once you will press enter, so it will install. So I'll just press enter and it will tell me that you have already installed all of these. So it's just telling me that. So as you can see, all of these libraries are installed with me. And after that, once you have installed this, and then you have to install pip install numpy. So this is also a library, so you have to install it. So I already have installed it, so just ignore this for the time being because I'm not going to upgrade it right now. So and after that you have to install pip install matplotlib. So this is also library we will be using. So everything is installed with me. So if you have any kind of issues, you can just ask me, or you can just Google it, and it will give you a solution for that. And after that, once you have installed all these libraries, you have to just come to your file, your Jupyter file actually, and here you have to import all these libraries. So these are the libraries that we will be using. So this is it. And after that, so basically in classification, in object classification, we need data. So like a child, when like if a child has to remind something, so what we do is basically we just tell him one thing again and again and again and again, so it reminds. So to remind, we have to like read it again and again, or we have to watch it again and again. So the same is the case is with this model. So we have to gather a lot of pictures. So there are a lot of ways to do it. So basically, let me show you how to do it. So first thing is that we have to specify a path. So we specified a path data, that we have a folder data, and for that let me just open it. So I have a folder data, so you'll just come and create here for name folder, and then you will just name the folder anything you want, but you have to give it here. Okay. And after that, why I did this, let me show you. Like, so when I have data folder, so I will need different kind of images. So um, I can't just use same images because that will overdefine, that will underdefine my model. So I'll use a vast number of images and different type of images. So basically here they are. So let me show you. So these are the images of my model. So basically what I'm training here is I'm training recyclable and non-recyclable objects. You can use any kind of model, and I gathered all these images from Google. So what you can do, you can use different ways. There are different ways to gather data. One way is like, if I need recyclable objects, so I'll just Google it, and my internet speed is a bit slow. So basically what will happen is you will have all these images, right? So these are not quite the one you want, but you can do just search about them. So I'll just let me type here happy or dogs. Let me do it. So if you want to identify between dogs and cats, so I just search dogs. So what I'll do is I'll just download all these images. So instead of downloading all these images one by one, like you use one right click and then you open the picture, you save it, so it will take a lot of time. So what you need is you need an extension. So this is an extension with me. Oh, and it's called download all images. So you just saw that I just clicked here, and it will download all the images like that have loaded on this web page. So it will download all these images in one single folder. So what you have to do is you just have to copy those pictures here, and once you have copied here all those pictures, so here then you have to divide them into two classes. So one is like if I want to do between dogs and cat, there will be a folder of dogs and there will be a folder of cat. So here I have folder of organic and I have folder of recyclable objects. Okay, so you will download all these images, and there are different websites that give you data sets. There is a one called Kaggle. I think yes, it's kaggle.com. So there is a lot of data set is already present here. So once you have your data set, you will just store it in data directory, and it's for in my case it's data. Okay, and in data I have two more folders, like the number of classes is the same as the number of folders. So I have only two classes, objects and organic and recyclable. You can have the one you want, doesn't matter. And so the next thing is now, as I downloaded it from Google, so there is a significant chance that it might not be, all the images might not be in these four forms, but our model. And but the thing is that OpenCV can only read few types of images. Like it cannot read, sometimes we have picture downloaded in .html format, so it's not just a picture, it's basically the link to the picture. So actually we have to delete those from our folder. So we can delete them manually, like we can just, like for example, if there is a picture that is like we can't open it. So for example, this picture is not, right now it's in .jpg, but suppose that it wasn't in .jpg. So we have to come here, and then we have to right click and delete all these images, so one by one. But the thing is that um, we have developed a program actually, and using this program you can delete all the unwanted images. So I just double checked. So for double checking, one thing I am checking is that the picture should be in this format, in these format, either it's JPEG or JPG or BMP or PNG. So these four formats, so picture should be in these four formats. And the second thing is that I'm opening it with cv2 dot I'm read image path. So if it will be, if it will open, if cv2 will be, if cv2 is succeeded in opening it, so it will just leave the picture. And if it's not able to open the picture, so it will delete it. So these two are the checks that I have used in this case. So you can just use this. Let me just run it with you. Okay, so you have to run it by using shift and enter. So it's running, actually it's importing libraries, so it's taking a bit of time for me. But hope that for you it won't take time, because my laptop is a bit slow. And then you have to do for this, and then you have to do for this. And actually I'm not doing it because maybe it will take some time, but for me I've already done it. So I have no need for doing it again. Okay, and then so then after that, I'm using TensorFlow library. So what actually happening in the background, I don't think that like we need to understand it right now. And I don't even know it by myself right now, but I'll for sure I will have some, I'll go into details once I'm good with it. So you have to just shift and enter this one too, and it will just measure the number of images, the number of file, and it will just create a data set from this directory. So it used data directory data, the folder data, and it created image data sets. So it is basically creating data set for the further processing. So it is telling you that I have 22,564 files in there. Okay, So yes, you can just use this command, and after that you can put two question marks, and it will tell you that what do I need in this here, and what it will give you output as output. So you can just read it from here, or you can just Google it and you can read it there. Okay. So after that, we have to, like, sometimes the pictures are not all the pictures are not equal. So but for the processing we need all the pictures at same size. So for that we will just use this command, and once we are done with that, we will just move it to here. And here what we are doing, we are actually creating different batches of different multiple batches of images. So that for the processing, so it's a way of doing it. And so what it is doing, it's like we are using iterator, so numpy iterator. So it will basically, what it will do is it will just shuffle all the images. So once I'll just run it, so as you can see here, so you just saw some pictures, and it's basically a batch of 8 objects. So I'll just run it again, you will see different images. So it's just iterating all the images. It will go all through, it will go through all the images. But right now we are just going through few, we can just show few images, that's why you can't see it. Let me delete it. Okay. And then we have to see the length of data. So actually user, we have 706 batches. So in one batch we have around like we have, let me see how many we have. Wait a second. So here we have here. Here. So this is the number of in these are all the images we have. So basically the zero mean for class 1 and 1 mean for class 2. So it is basically this. So what actually this model has done is the images from this folder, actually this folder. So there are two folders. So it just labeled all the images in this folder as 0, and all the images in this folder as 1. So for the for the program, the images in that folder will be 0, and all the organic pictures will be 0, and all the recyclable pictures are 1 for the program. Okay. So this is one batch, and like these we have 706 batches. Okay. So what we have to do next is we have to split these 706 batches into three different types. One will be train, the other one will for validation, and the third one will be for testing. So for train size we will use 70% of this, and for other two we will be using like 20% in, like we will be using 20 what should I say? We'll be using 20% of the data sets in validation, and 10% in test, and 70% will be for 70% will be for training. So I'll just run it and it's done, and then you can see train size, validation size, and test size. So this is it. And after that we have to take the data from all those places. So we'll just do it. So actually train is the data of these 494 batches. So the pictures in these 494 batches are stored in train right now, and these 142 are stored in val, and these 71 are stored in test. Okay. So the next thing is, now we are going towards the training of our model. So basically how it works, so this is now we will be covering in this video. So and you don't need to like know it right now. You can go into details by yourself, and we will just go through it. Okay. So by running these, so actually what I did is I imported some of the packages from TensorFlow.carousel model, and also .layers. So it uses convolution 2D and max boolean 2D, all these packages for the training, for the to train our model we will be using all these. So it's basically using CNN, so convolutional neural networks. So This is how it works. So this is a syntax, so you just have to just use this right now for the time being. Okay, and this is, so just run, and then we have done it. And here you have to like do it. And here you have the summary. You have 448 convolutional 2D, and then 4640. So it is actually the number of features it will be extracting. So the number of features this program will extract from one image will be this much. So not, I think not the one image, the total, yes. Total extractable features that this program will extract is this much. So you can just see that how good the program will be trained once it will use all these extractable features. Okay, so now once we have done all these, we have to just we have to store the when we will start training our model, we have to store all the data in somewhere. So for that we will be creating a folder named as logs. So just going back to the folder, here you can see I have the folder already here. So you just have to create a new folder with the name of logs, or whatever you want, but you have to give the name here again. Okay, so logs, I'll just do it. And okay, and here I'm giving this to the directly to the TensorBoard callback. And here, so by using this command you will be training your model. I'm not doing it right now because I have already done it. So the model is trained for me. And you have to use here at least, I think, let's say 20 epochs. Let's do it with 20 epochs. Okay, so what's basically epochs is like training the from the data sets, or for one epoch it will train from all the data set for once. So by 20 epochs means that it will be going through all those data sets, all the batches 20 times. Okay, so once it will extract all these features, and then it will come back again, and then it will come back again, and then for 20 times it will extract all those features. Okay, so this is it. Once you will run it, your model will be trained, and your model will be trained, and all the data will be stored in logs. Okay, and by running this, when you will run this, you will see a plot like this. So basically it's not a good kind of plot, because it's just it's an ideal kind of plot. Because when the last time I ran it, I used only two epochs for just I don't know why I used two epochs, but I just did it. So you will just run this line, and by running this line you will see a graph, and that graph will tell you that how much data how much features we have lost, how much features the program lost while reading the images, and while extracting the features, and how much we lost in validating all those data set. And once you have done it, you can actually check the precision, you can actually check the accuracy of all this thing that you have done here. So for that, actually this is not like necessary for right now, but yes, it is necessary. Like you should know that how much accuracy your program have. So by using this, you can actually have your precision and recall and binary accuracy. Okay, and once you have done it, you have to go through I mean, why I'm not going through all these right now, because right now I haven't run this thing. So if I haven't run this thing, then it won't be. Basically, let me run it for once. Okay, let me do it for once, just once. So if I do it for once, still it's taking 13 minutes for me, because my laptop is too slow. So maybe I should just explain this to you. Okay, and then we will go back again and we will do it. So here, okay. So once you have done all these things, once you have came up all to this way, now what we have to do is we have to test all these things. So for that we will use the cv2.mread, and I have a picture, like I downloaded few pictures with me here, all these pictures, and some are organic and some are like banana bottle and all these things. Okay, so what you will have to do is you have to import the picture, you have to resize it to the ratio at which let me show you here, at which you have scaled it. Okay, So we have programmed our model to 256, so you have to use 256. Okay, and then we use matplotlib to actually show the image. So once we have done it, then we have to predict the model. Okay, so we actually predicted it, and it told us that your object is this one. So if it is between 0 and 0.5, then we can say that it's like it is from the class 0, but when it is between 0.5 and 1, we can say that it's from the class 1. So these, like this way you can have your model trained. Okay, so up till now we have trained our model, we haven't used it, actually we haven't saved the model. So first thing we will do is we will just save the model. So for that we will just use this model, load model package from TensorFlow, and by using this we will use actually, so we have to create another folder named models where we will store this model. Okay, and we give this folder here, and the the name of the file will be this one. So .h5 is actually um, basically the it is the type in which the file format, it's a file format, and this is the name of the file. You can name it whatever you want. Okay, okay, so we just saved it to the we just saved it in that folder. Okay, so once we have saved it, our program is complete. So now the thing is that we have to use that model. So for using that model, we will import that model again. We will import the file, so it's new model, and we have to use load model. We will load the model from models and image classifiers. So it's actually basically from this model and image classified h5. Okay, so once we have loaded the model, we will just do that thing again. We will just read an image and plot it here, and then we will use this command. So this is basically the command that will be used to actually predict what kind of object this is. So it just predicted that it is recyclable. So basically the can is a recyclable product. So it just predicted that it's recyclable. Okay, so this was all of it, and I think it's still running. Yes, it's still running, so you can do it yourself. So this was all from by for training your model. This is all you need. Okay, that's it. Thank you.